Alright, welcome back to this video series in which we talk about the different hyperparameters of training a neural network and the considerations we need to take when developing a neural network model. In this video, we will talk about one aspect that can make the difference between a working neural net and a dysfunctional neural net, and that is the normalization of the neural network inputs and outputs. A neural network with normalized input can converge much faster compared to an unnormalized counterpart. This can be shown when you deep dive into how the backpropagation algorithm works and the derivatives of the loss with respect to the weights, but we will not go into the depth of that in this video. If you want to know more on the subject, I recommend this article by Tim Stotner, if I pronounce the name correctly. I will leave the link in the description. What we will do instead is to show this fact via an example. I will use the floor function and I will train two models, one on the function around 0 with a distance of 4 and another one around 200 with the same distance of 4. So let's train the model to see how the networks will estimate them. Okay, so as you can see, the shape of the function we want to estimate is exactly the same in both configurations. It's just shifted in the second one. In the first one, the estimation is very close to the actual function, whereas in the second one, the error is too high and the model failed to estimate the steps. Even in the first one, you can see that the estimations close to 0 are much better compared to the borders of the domain. Another key point to consider here is that you should use the same normalization on the training set and when you are using the model for inference. For example, if the mean of the feature A in the training set is 0.5 with a standard deviation of 2.4, you should keep these values and apply the same transformation to the data that you want to feed to the model for inference. The reason for that is that the network is expecting data with the same distribution, and if you use the mean and standard deviation of the test set, it is going to be different than the one of the training set, whereas your network will interpret those values with the same distribution, thus it will have the wrong inference. In the next video, I will go over the effect of epoch count during the training. So if you want to follow along with the series, please consider to subscribe to the channel and hit the bell icon to be notified as soon as I publish them. Also, if you enjoyed this video, please give me a thumbs up so others can find on YouTube as well.